Okay, so once again, hello everyone. So this is Aditya, and today I'm going to discuss the assignment number 8, which was rolled out the previous year. Feel free to pitch in when you feel that you are not understanding and then you have queries. If queries remain even after the end of this lecture, feel free to get them addressed the next time we are meeting on this particular platform. So, the first question, which was there in the assignment, was related to figuring out the RMS of this particular waveform. Now, before I go into the solution of this particular problem, let me address two very important concepts. The first concept is that of period, right, of a continuous waveform. So please understand that the period is continuous. So the period of a waveform, okay, so this is not the first question. This is the first question. Sorry. So this is the repetitive waveform here, which is given to you, right? So the period of any signal is the value of in time after which it is repeating, right? So if you'll see, like this is not the exact definition of period. For the exact definition of period, you can look into textbooks on signals and system. There, they will kind of give you the exact definition of period for both continuous as well as for discrete like functions, right? So, but then for the time being, I'll just put it in a simple manner for you to understand that period of a continuous signal can be thought of the duration after which it is repeating in the same manner, right? So here you can see that this for the period of 2t, the waveform is of some shape, and after some 2t time, the waveform kind of repeats, right? So now by looking at this particular figure, you have understood that look, the period of this particular waveform is 2t. So Sharath, please unmute yourself and ask your query. So just let me stop presentation and then kind of represent it. Maybe that will kind of solve it. Okay. Can you see the screen now, Sharath? Hello, Sharath. Can you see this? Okay, that's great then. I think I forgot to the previous time I forgot to share the screen. So yeah, apologies from that side. But then since it would be there on net, you can again view the first a couple of minutes, right? So I was saying, Sharad, that you need to like the most of it was verbal. So anyways, you didn't miss much. So any queries, guys? Like Sharad. Okay, so you are raising your hand. That's why. So I was telling about period. So you need to look at the waveform and kind of, and after that try to identify what's the duration after which it is repeating. So if you can see this particular waveform on your screen, you can see that it is repeating after every 2t time interval, right? So 2t is my period. Good. So this thing is like observed and reduced, and then second comes the RMS quantity, right? So RMS of any function is given by uh, this particular formula. So it is what I have written over here is function is f, right? So here the function is I, so it can be anything. You can write whatever you want. So function square, whatever the function is given, just square it and then integrate it with respect to time and integrate it over what region? So you have to integrate it over the time t. What is t? The t is the period of the function, right? So here I'll be integrating it over 2t time period, right? Okay. The second thing is that you have to divide it with the total time period. So you just divide it, and then whatever the value comes out, you take a square root of it, right? So this will give you root mean square, root mean square, right? So this is how you figure out the value of any RMS. You figure out the RMS of any function, right? Now, clearly, from this particular equation, let me call it equation number one, you realize that after seeing this equation that you have to have a value of some f of t to integrate it, right? So, what's the value of f of t here? Or for that matter, what's the value of I of t here, right? So I of t here, you can see that it has some linear equation between 0 to t by 2, right? And some other linear equation between t by 2 to t, because it is slipping to minus 2p and here it is ip. So the slope must be different and hence the equation must be different. And it's a constant between this region, right? And it's a zero value between these two, right? So let me just write this. So it's these kinds of functions are known as piecewise linear function, right? So it is piecewise linear. So here to here, okay. So here to here it is linear, and then again in the region B it is linear. Again in the region C it is a kind of a linear function, rather a constant function, and in region D also it's a constant function with a value 0, right? So these kinds of function comes in the category of piecewise linear, just kind of information. More on this will be taught to you on like in your course on signals and systems, right? But for the time being, let me just write the value of I of t. So I of t is 2ip divided by t minus t by 2, right? And t belonging to 0 to t by 2, correct? And then the second quantity will be equal to minus 4ip by t minus t by 2, t belonging to t by 2 to capital T. So I've just worked it out. You guys can use basic geometry to figure out what is the equation of these straight lines, right? And the third is pretty straightforward. It is just IT is nothing but IP, right? No need to think over there. Okay, there is some problem with, yeah. 3 by 2, comma, this is comma, 3 by 2. And then the fourth quantity is going to be 0 for the time t belonging to 3 by 2 to 3t by 2 to capital 2t, right? So now we have split this particular waveform into its equivalent piecewise equations. It would be easier for us to kind of put it in this particular equation and then try to figure out the RMS quantity. So the remaining thing is like basics of integration. It's not a big deal. So what you have to do is you have to take a square of this particular quantity, right? So let me write the complete equation, and after that you can do the integration, right? So it will be equal to I of t RMS, right? So I RMS. Let me just write it. I RMS is equal to 0 to t by 2 4 I square over t square t minus t by 2 whole square dt plus 0 to sorry, t by 2 to t 16 ip square divided by t square t minus t by 2 whole square dt plus t to 3t by 2 ip square dt plus 0, right? And you have to divide it by 2t, right? Because this is the like this will be equal to 2t. And once you have like figured out what is the value of this particular quantity, all you have to do is take a square root of it, right? So square root of this entire thing will give you the RMS quantity. So you figure it out, and after doing some like algebraic calculations over here, you will figure that the answer comes out to be 0.816 IP. So the point I want you to take note of is the two things which I have stated at the beginning of this problem. First thing is that you must, whenever a function is given to you in electrical engineering, or for that matter in any form of mathematics as well, try to figure out if that function has some periodicity associated with it, right? And then will come other such things like is it even, is it odd, is it what kind of periodicity does it show? Does it show quarter wave symmetry? So let me just write it down. Look into textbook to understand these things better. So one thing is even function. Second thing is odd function. Third thing is that quarter wave symmetry. So 1, 2, 3, right? So try to look them up in textbooks, and try to figure out the meaning of this. I am very sure that you would have been introduced to even function and odd function in your intermediate classes, and the quarter wave symmetry is something which might be something new which you are hearing for the first time. Try to look it up. It would be very beneficial for you, right? Now, with this information, let me just change to start the second problem. So, before I progress, is there any doubt here, Sharad? Sharad, are you? Okay. You understand basics of geometry, right? 4T. Where is 4IP? So you have to write the equation of this particular line. How do you write the equation of line? Tell me. You have 2 points with you, point A and point B, with x1, y1 as its uh, coordinate and x2, y2 as its coordinate. How do you write a equation of line between point A and point B? You have learnt in your higher secondary education that equation of line between 2 points is given by y is equals to y minus x1 uh, and then x minus x1 y minus y1 x minus x1 is equals to slope m, right? What is slope m? Slope m is nothing but y2 minus y1 divided by x2 minus x1, right? So this is the equation of a line which is passing through x1, y1 with a slope of this particular quantity, right? Now what are these two A and B points over here? These points are x1 will be equal to t by 2. What is y1? y1 will be equal to 0. What is B? B is t t, and then the y2 coordinate will be equal to minus 2it. So you substitute these particular coordinate values in this particular equation, you will get the equation of the line, which is represented here by this particular function. So did I solve your query? Okay. So try to revise your basics, like the basics of geometry, which you would have studied in your 10th, 12th, and those kinds of. And then that would be very helpful in your education now as well. So let me try to solve question number 2 over here, right? So just by looking at this particular waveform, I can see that it has some kind of a period associated with it, right? So the period is pi. Why pi? Because I see whatever the waveform is here, the same waveform is repeated between pi to 2 pi, right? So this is my period, right? Pi. So pi radian is my period, right? Okay, so far so good. Now what is required from you? The requirement from you is that you have to figure out the power, average power dissipated in the resistor. What is the average equation of average power? So let me write the equation of power. Power is Vrms square divided by resistance, right? This is the formula for power. We all have studied this this particular formula. So the only thing which is remaining here is that you have to figure out Vrms. Once you have the value of Vrms, you can square it and divide it by resistance to get the answer, right? Simple. So now I have already told you how to figure out RMS quantity, right? So what would be the RMS quantity? Again, the formula remains the same. So Vt square dt, integrate it over the time. The time here is that radian, it's in radian, so it will be pi, right? And then you divide it with time, and then you take a square root of it. You take a square root of it, right? This will give you the RMS value, right? So since it is very straightforward, because it's all constant, let me just write it out here, right? So the first quantity is going to be 100 square, right? And integrated over 0 to pi by 3, correct? And of course it is like dt here is d omega t. It should be d omega t because it's written in pi notion, right? So there is some like a minor error from the one who has said the question, because time is always in seconds, right? Or some functions of seconds. The units are basically of the x-axis must be in seconds if the axis is in time. So the person who has said the question should have written not written time over here, rather a function like omega t should be there, which would be kind of meeting this particular unit which the question has said. So anyways, like that's a minor detail. So just let me jump that, right? And then you can write over here d omega t, and then from pi by 3 to 2 pi by 3, 100 with a minus sign square d omega t, and then the third quantity is going to be again 100, right? So 100 square, and then 2 pi by 3 to pi, right? And d omega t. Of course, you have to take under root of this particular quantity and you have to divide it by pi, right? So it's very evident now that 100 square, like minus 100 square is 100 square. We know that, right? And every other thing in the integration is constant quantity. So the integration is just going to turn out to be 100 square, and then multiplied by pi by 3 plus pi by 3 plus pi by 3 divided by pi and under root. So this will give to you the value as 100. So this is like I'm just solving this particular values in here. So pi by 3 plus pi by 3 is nothing but pi. So pi and pi are cancelled, right? So it will give you 1. And then you can take the square root of 100 square, that is 100. So you get the value of VRMS as 100. Now once you have this value of VRMS as 100, you can substitute it over here. So it is 100 into 100 divided by resistance. Resistance is 25, and that is going to give your answer as 400 watts. So that means B is your correct answer, right? So I'm hoping that second number question is like you have understood question number second. If not, please feel free to unmute yourself and ask. Okay, that's great. Everybody else on the platform, I'm hoping you all have understood. If not, please unmute and ask. Okay, so no queries. I'm taking that everyone has understood. Let me proceed forward. So here in this particular question, they are asking you to figure out what is the current in this neutral wire, right? No. They are asking you what should be the value of R such that the current in neutral wire is equal to 0, right? Now we know from basics of electrical engineering, from basics of circuit theory, that IA plus IB plus IC must be equal to IN. Why do we know that? We know it from the basics of KCL, which we have covered extensively during our previous lectures, right? So we applied nodal equation at this particular node here. Let me call this node as node N, right? And whatever the current is coming in must go out. So whatever current coming in, these are the currents which are coming in, right, on the left hand side, must be equal to the current going out. This is the current which is going out. Now the question is saying that this current is equal to 0, right? And I have to find the value of R such that this constraint is met. Very simple, right? So how do you proceed forward? So IA, I know what is I. I is nothing but V divided by impedance, right? I is equals to V divided by impedance. So if the impedance, you have to write impedance can be any function of R, L and C, right? Depending upon how they are connected, right? So it has one real term and one imaginary term, right? So this is my imaginary term and this is my real term. This is my real term here, this is my imaginary term. So you know about these things from your basics of electrical engineering. So let me just write it down. So VAN, it will be VAN divided by R plus VBN divided by what is B? J10, right? And then the third quantity is going to be VCN divided by minus J10, right? And this is equals to 0. Okay. Now the value of AN is given to you. It's equal to 80. And value of BN is also given to you. It is 80 at an angle of minus 120 degree. And Cn is also given to you. It is 80 at an angle of minus 2. So it is a balanced voltage, right? What is a balanced voltage? Balanced voltage is three-phase balanced voltage. So it is A, B, and C, right? So it's a balanced voltage in that like the magnitudes are equal and it's displaced in phase by 120 degree, right? So so everything is like known to you now. right? Because VAN is known to you, VBN is known to you, VCN is known to you, all the denominators is known to you, right? So one equation, one unknown. Can you solve it? Yes, you can solve it, right? Because it has only one unknown and one equation. So when you solve it and then like I have solved it, like use your scientific calculator to solve it because like it has some J terms, right? So try get yourself acquainted with the scientific calculators. It would be helpful for you during the entire run of electrical engineering, right? So if you don't have a scientific calculator, purchase it and try to get yourself acquainted with it. So when you put all these things in the calculator and then try to solve, what you will get is the resistance R comes out to be 5.77 ohm, right? Now 5.77 is in between 5.7 and 5.8, and therefore that becomes your answer. So is there any query regarding this particular question? If yes, please unmute yourself and ask. Okay, so no queries. I take it that everyone on the platform has understood it. So let me try to solve question number 4. So the question number 4 is asking you to figure out the current in the ammeter A, right? Uh, the information which is provided to you in the question is the current in ammeter A1 and current in ammeter A2. Now the first question I would want to ask and feel free to pitch in like if you know the answer. So what does a ammeter measure? Does it measure peak quantity? Does it measure RMS quantity? What does it measure? Good. Does RMS quantity, does it also measure the phase of the RMS quantity or only the magnitude? Only magnitude. That is the correct answer. So the regular ammeters which you have, they don't give you information about phase. The ones which you are using in your labs, they don't give information about the phase. It will just give you the information about the magnitude, and that will be the RMS quantity of that particular signal, right? So what's given to you here is a, ideal ammeter. So you just understand that it's giving you the value of the RMS quantity, right? So what is the reading of A1? It is 8 ampere. What is the reading of A2? It is 15 ampere, right? A1 and A2, right? Now, if I'll ask you, what is the phase of A1? What should be the phase of A1? What would you say? If given that a phase must always be defined with some reference, so let me just say that this is the reference over here. V at an angle of 0 degree is the voltage across these two nodes, right? Across node, let me say P and Q. So this node is P, this node is Q. So the voltage across the node is V at an angle of 0 degree. So what should be the angle of A1, mathematically speaking? 0. That's very correct. Why it is 0? Because it's a resistance, right? How about A2? No, actually, I'll ask you to rethink. Let me just help you out here. So the current in a capacitance is will be given by V at an angle of 0 degree divided by ZC, correct? And what is ZC? ZC is V at an angle of 0 divided by 1 over J omega C, correct? Right? So this implies that the current will be A2 at an angle of 90 degree plus 90 degree, right? Or you can say whatever A2 comes, just put a J over there, right? So it's clear that the resultant will be equal to the hypotenuse of the right angle triangle, correct? Or you can put it in your calculator also, no big deal there. So you put into your calculator 8 plus 15j and then try to figure out the modulus of it. You will get it as 17 ampere, right? And some angle, some delta angle. I'm not bothered about that. So, or you can use the right angle triangle property. You can say that, look, this is 8, this is 15. Okay, where did it go? This is 8, this is 15. So what is the hypotenuse? So 8 square plus 15 square under root is your hypotenuse, and this is my overall quantity which will be coming in from here, right? Right, Sharad? Right. And whatever is coming in will be measured by the RMS of the same will be measured by A3. So since these two are already RMS, it will be measuring the RMS. This is the RMS anyways. So you will get the answer as 17, right? So I'm hoping this problem is clear to everyone present over here. Uh, Let me now move to question number 5, right? So the question number 5 is stating that you have to figure out uh, the peak value of the steady state current, right? Peak value, remember this, right? Steady state current through the 20 ohm resistance, right? So what the first thing which I should ask or rather I should inform is that the XL is given by j omega L. I'm hoping that you guys already know this, but just let me rewrite it for the purpose of revision. So, and XC is going to be given by 1 by j omega C, right? And the resistance is just R, right? So the value of omega is subject to the excitation function, right? So what's the excitation function over here? This is my excitation function. This is the external power which is supplying this particular circuit, right? So a circuit can have more than one excitation function. In that particular case, you will have to use something known as superposition theorem, right? So fortunately for you guys, there is only one excitation function, right? So it is just 20 sine omega t. You could have other excitation function as well. Let's say you could have had a voltage source coming over here as 60 sine t by 1000. So instead of 1000 t, it can be t by 1000, right? And then you will have to identify the number of independently and dependent excitation functions, and then use the superposition theorem for every excitation function to figure out how things are working in your circuit. So that can be that can be one uh, that can be one possible thing which you can explore in your free time, right? But for the time being now here, just try to see that there is only one excitation function, so life is simple over here, right? Now, the second thing which you must observe here is that what is the excitation frequency, right? So this here is your excitation frequency, right? So it's a fundamental, the fundamental of this particular excitation is 1000. This is your omega, right? So what is your XL? XL will be whatever the value of L into omega, right? What is omega? It is 1000. So you just have to put 1000 and then you will figure out the XL of every like element. And similarly, you can figure out what is XC. So now we see that these two things are coming in parallel. Okay, these two things are coming in parallel, right? So just let me name them, right? Uh, let me name it as X1 and X2 and X3 and X4, right? Now, the parallel connection of these must be the same thing which we have studied earlier, right? So x1, x2 divided by x1 plus x2 is the x equivalent, right? And similarly, for this, it will be equal to x3, x4 divided by x3 plus x4. And this is the x equivalent 2, right? So this is x equivalent 1, x equivalent 2, right? So let us try to figure out what is the x equivalent 1, right? So x equivalent 1 can be given as uh, x1 will what will be x1? X1 will be equal to 1 by uh, j. Omega is 1000 and this is 40 into 10 power minus 6, right? So this is 1, right? And the other quantity is going to be x2, right? X2 will be equal to j into 25 into 10 power minus 3 into 1000, right? Now, if you will try to solve them, what will come out to be is that this is going to be I'm guessing just let me write it minus j 25, right? And this quantity here it's going to be plus 25j, right? Because it is 10 power minus 3 and then multiplied by 1000, so you are left with 25j, right? So if x1 and x2 are equal in magnitude but opposite in sign, that implies that the sum of the denominator is going to be 0, right? So x1 and x2 is going to be some finite value. Oh my God. Some finite value divided by minus 25j plus 25j. This gives you answer as infinity. So the effective value of impedance of this particular network x equivalent 1 is infinity, right? Similarly, if you will do the calculation for this particular branch over here, you will figure out that x3 is 2j and x4 is minus 2j, right? And if that is the case, this implies that x equivalent 2 is also equal to infinity. Now, if both are equal to infinity, that implies that no current is going to flow through them. So you can redraw the circuit now. Oh, yeah. You can redraw the circuit now with open here and open here, right? And then this is the final circuit, right? So if you have the elements 4, 2 and 4, all these are what's happening? 4, 2 and 4, right? And all these are resistive elements, right? So what you can do is you can just divide the V, that is 20 sine 1000 t divided by the resistance, which is total resistance, which is equals to 4 plus 2 plus 4, that is 10. So you are left with V divided by resistance is R, V divided by resistance is current. Some problem is there. And you equate it to I, you see that the value is equals to 2 and that is there here. So this way you can try to figure out solutions to such problems, right? Always remember, in like competitive examinations which you are going to give in days to come, things are going to be like solving to such kind of easy scenarios, right? Especially if it is for a single point question. But in your exams, like internal exams, which you will be having in your colleges, right? There is a good possibility that you will have more than one excitation function. So this is excitation function, right? And then there can be more than one excitation function which can be both independent and dependent, right? So try to figure, like try to create random circuits on your own, right? And try to simulate them using software applications like MATLAB, right? So uh, MATLAB, right? So you can create whatever kind of circuits you want and you can simulate them in MATLAB. Once you simulate them, you can check your answers on the same simulation software, right? So let's suppose hypothetically, I can put a voltage dependent source over here, right? And that current will be dependent upon, let's say, I over here, right? And this current is going to be independent in such a manner that it will be I at an angle of let me name it I4. So this will be I4 at an angle of some 50 degree, right? So just by like playing with the circuit, you can create your own circuit and then try to solve those circuits numerically, and then try to figure the solutions out on MATLAB, and then try to re-verify your answers. So that brings us to the end of today's presentation. I'm hoping you understood this particular problem. If not, please feel free to unmute and ask your query. Okay. If there is no query, I'm hoping that you guys have understood it. My colleague is going to take the next hour. So I request you to join her presentation, and she will be taking it up from here. So thank you guys for joining in. Like if you have any queries, not just limited to this, please feel free to ask. We have some couple of minutes left with us. I can address your queries now. So not just limited to this course, in general related to electrical engineering. Okay, I'm guessing that there is no queries, so I'm stopping the presentation, and I'm